Hello there, and welcome to the Sleep Journal. Tonight, we are going to travel to the flattest, quietest place on the entire surface of our planet. Not a desert, not a frozen ice sheet. Somewhere far beneath the ocean, in complete darkness, lies a landscape so flat, so still, and so undisturbed that a single footprint left there could remain visible for hundreds or even thousands of years. Scientists call it the abyssal plain. It is not a single location, but a type of landscape found scattered across every major ocean on Earth, typically lying between 3 and 6 kilometers below the surface, far below the reach of sunlight, far below the reach of storms, far below anything resembling the ordinary rhythm of weather and tide that shapes the world we know. Down there, the seafloor stretches out for hundreds, sometimes thousands of miles, almost perfectly level, covered in a soft, fine layer of sediment that has been settling gently for millions of years, one microscopic particle at a time. There are no mountains here, no canyons, no dramatic cliffs or sudden drops, just a vast, quiet expanse, as flat and featureless as anything found anywhere on the surface of our planet, broken only occasionally by a lone volcanic peak or the faint, ancient trail of some creature that passed through many years before. In fact, abyssal plains are widely considered the largest single type of habitat, by surface area, on the entire planet, covering more of the Earth's surface than every desert, every forest, and every grassland combined. And yet, almost no one has ever seen one, let alone thought about it, before drifting off to sleep. Tonight, that changes. Before we begin, if evenings like this help you unwind, feel free to like, subscribe, or leave a gentle comment below. It helps other tired minds find their way here. But for now, there's nothing you need to do. Let your jaw unclench. Let your shoulders drop. Let your breathing slow down into something as calm and as unhurried as the vast, silent plain we are about to visit together. And as your mind begins to soften, join me. Let us begin. The first detailed maps of the deep ocean floor were only produced in the middle of the 20th century, using sound waves bounced off the seafloor from research ships slowly crossing the open ocean. What those early surveys revealed surprised almost everyone involved. Rather than a jagged, uneven seabed, mirroring the mountains and valleys of dry land, much of the deep ocean floor turned out to be extraordinarily flat, smoother in relative terms than almost anywhere on the continents above. It is worth pausing for a moment on just how counterintuitive this discovery felt at the time. For most of human history, whatever lay beneath the ocean's surface was simply unknown, filled in by imagination rather than evidence, often pictured as a mysterious, jagged underworld, mirroring the dramatic terrain of mountains and canyons found on land. The reality, once properly measured, turned out to be something quite different, and in its own way, far stranger. A landscape defined not by drama, but by patience. Not by sudden, dramatic geological events, but by the slow, cumulative effect of an almost unimaginable number of tiny, quiet actions, repeated endlessly, across timescales longer than anything most of us are accustomed to thinking about in the course of an ordinary day. Tonight, we are simply going to sit with that patience for a while, letting its slow, steady rhythm settle gently into your own body, as your own day gently, quietly, comes to an end. Consider for a moment how differently this landscape came to be understood compared to almost everywhere else on the planet. The mountains of Earth were mapped by explorers, climbing them directly, on foot, over generations. The deserts were crossed, slowly, by caravans and expeditions, their contours gradually recorded firsthand. The abyssal plain, by contrast, had to be discovered indirectly, through sound and pressure, and careful, patient instruments, lowered gently into darkness from ships floating calmly on the surface far above. It remains, in many ways, a landscape known to us not through direct footsteps, but through quiet, careful listening, a fitting way, perhaps, to begin an evening built entirely around listening and resting and letting go. To understand how a landscape this vast and this flat actually forms, we need to start with the ocean crust itself, far from any continent, out where new seafloor is constantly being created, along enormous underwater mountain ranges called mid-ocean ridges. Molten rock rises up from deep within the earth, cools and solidifies, forming brand new ocean crust that slowly spreads outward in both directions, like a conveyor belt moving at a pace of only a few centimeters each year. When this crust first forms, it is anything but flat. It emerges as jagged, uneven volcanic rock, full of ridges, cracks, and small hills, shaped by the violent, chaotic process of its own creation. But as this new crust drifts slowly away from the ridge where it was born, gravity, sediment, and time begin a long, patient process of smoothing everything out. Over millions of years, a constant, gentle rain of material settles down from the productive waters far above, the same slow drift of organic debris we have explored on other nights, joined here by fine mineral particles carried by ocean currents from distant rivers, by volcanic ash scattered from eruptions thousands of miles away, and by the microscopic shells of countless tiny organisms that live into the permanent darkness below. This sediment accumulates with remarkable evenness, settling into every crack and hollow of the original volcanic rock, gradually burying the jagged terrain beneath a smooth, thick blanket, layer upon layer, century after century, until what was once a rough, uneven seafloor becomes something close to perfectly flat. In some regions of the deep ocean, this sediment layer can grow to be hundreds of meters thick, an almost unimaginable accumulation, built entirely from particles too small to see individually, drifting downward, one at a time, for tens of millions of years without interruption. The abyssal plains found in the Atlantic Ocean, for instance, tend to be especially flat and especially smooth, largely because sediment reaching them travels relatively short distances from nearby continents, allowing thick, even deposits to build up steadily over time. In parts of the Pacific Ocean, by contrast, some abyssal plains remain slightly less complete in their smoothing, still showing faint traces of the volcanic terrain that lies buried beneath them, visible only through sensitive instruments capable of detecting the subtle contours hidden under the sediment's soft, patient covering. This slow accumulation process is not uniform everywhere across the ocean. Regions located far from any major river, or far from productive surface waters rich in marine life, tend to accumulate sediment far more slowly, sometimes only a few millimeters every 1,000 years, producing some of the flattest and most undisturbed terrain found anywhere on the entire planet. In these particularly remote, particularly stable regions, the ocean floor can remain essentially unchanged for millions of years at a stretch, disturbed only rarely by the occasional passage of a large creature, or the extremely gradual settling of a fresh layer of sediment, arriving so slowly that any single human observer, even watching patiently for an entire lifetime. Scientists studying these especially stable regions have come to regard them as among the most geologically quiet places on Earth. Environments where the pace of change is measured not in seasons, or even centuries, but in units of geological time so vast that ordinary human patience struggles to hold them comfortably in mind. It is worth noting that this same slow sediment blanket also plays a quiet role in preserving whatever lies beneath it. Ancient volcanic rock, buried gradually beneath accumulating layers of fine particles, becomes remarkably well protected from the kind of weathering and erosion that reshapes exposed terrain elsewhere on the planet. In a sense, the abyssal plain acts as both sculptor and archivist at once, smoothing the surface visible from above, while simultaneously preserving, largely untouched, the original volcanic landscape hidden safely beneath its patient, undisturbed covering. The sheer scale of the abyssal plains is difficult to grasp from the surface of the Earth, where nearly everything we experience directly is shaped by hills, valleys, coastlines, and other visible boundaries. Abyssal plains, by contrast, exist almost entirely without such boundaries. A single plain can stretch for hundreds of miles in every direction, occasionally extending across an area larger than many entire countries, all of it maintaining nearly the same gentle, almost imperceptible slope, tilting so slightly that the difference in depth across many miles might amount to only a few meters. Researchers who have surveyed these regions using sonar and satellite gravity measurements describe some abyssal plains as flatter than any comparable area found anywhere on dry land, smoother even than the flattest deserts, or the most level agricultural plains found on the continents above. Altogether, Scientists estimate that abyssal plains cover somewhere between 40 and 50% of the entire surface of planet Earth, an extraordinary figure that surprises most people encountering it for the first time. We tend to picture our planet in terms of its visible surface, mountains, coastlines, forests, and cities, largely forgetting that the majority of Earth's actual surface lies hidden beneath several kilometers of water, in a landscape almost nobody will ever personally witness. This vast area remained essentially unmapped in any detail until surprisingly recently in human history. For most of the 20th century, our understanding of the deep ocean floor came primarily from scattered soundings, individual depth measurements taken one at a time by ships slowly crossing the open ocean, leaving enormous gaps in our knowledge between each measurement. It was only with the development of modern multi-beam sonar systems capable of mapping wide swaths of seafloor continuously as a ship travels that scientists finally began producing detailed, continuous maps of these enormous, flat expanses. Even today, despite decades of steady progress, a significant portion of the world's abyssal plains remains less thoroughly mapped than the visible surface of the Moon, or Mars, simply because water, unlike open space, makes remote sensing from above extraordinarily difficult, requiring ships and specialized instruments to survey the ocean floor directly, one slow, patient pass at a time, for our entire planet. Even now, with modern mapping technology steadily improving each year, scientists estimate that only a relatively small fraction of the world's abyssal plains have been surveyed in the kind of fine, detailed resolution routinely available for the surface of the Moon or Mars. This is not, in most cases, a matter of technological limitation, but simply one of scale and time. Mapping the entire deep ocean floor at high resolution would require thousands of research vessels working continuously for many years, a level of sustained global effort that has never quite materialized, spread thin instead across smaller, more targeted expeditions, each one gradually adding a small, careful piece to an enormous, unfinished puzzle. In this sense, the abyssal plain remains, even today, one of the last great unexplored frontiers on our own planet, closer, in terms of how thoroughly it has been mapped, to the surface of a distant world, than to anywhere most of us could ever hope to visit ourselves. Some oceanographers have noted, with a certain wry appreciation, that we possess more detailed maps of the far side of the Moon than we do of significant portions of our own ocean floor, an observation that says less about any lack of scientific interest and more about the sheer physical difficulty involved in surveying an environment that resists remote observation as thoroughly as the deep ocean does almost every form of energy we might otherwise use to study it from a comfortable distance above. And yet, slowly, patiently, one careful survey at a time, that picture continues to fill in, a little more completely with each passing year, exactly the way the abyssal plain itself was built, not through any single dramatic effort, but through countless small, patient contributions, each one adding just a little more understanding to a landscape that has been quietly waiting, largely unnoticed, for longer than human curiosity has existed to notice it at all. Despite its vast size and its remarkable flatness, the abyssal plain is far from a lifeless void. Life exists here, though in forms, and at a pace, dramatically different from almost anywhere else on the planet. Because sunlight cannot reach these depths, nothing resembling ordinary plant life can grow directly on the abyssal plain. Instead, nearly every creature living here depends, directly or indirectly, on the same slow, patient rain of organic material we explored during our earlier journey through the twilight zone. Marine snow, settling gently down from the productive waters far above, providing the only meaningful source of food in an otherwise resource-poor environment. Because this food supply is so thin and so unpredictable, life on the abyssal plain has adapted in remarkable ways. Many creatures here move slowly and deliberately, conserving energy wherever possible, since a burst of rapid movement might easily consume more energy than a typical meal could ever replace. Sea cucumbers, some of the most common creatures found across abyssal plains worldwide, glide slowly across the soft sediment, ingesting mouthfuls of mud as they go, patiently extracting whatever traces of nutrition remain within the settled marine snow, before leaving behind long, winding trails across the otherwise undisturbed seafloor. Certain species of abyssal fish have evolved extraordinarily low metabolic rates, allowing them to survive for extended periods between meals, sometimes going many months without feeding at all, patiently conserving their limited energy reserves until the next opportunity happens to drift within reach. Scientists studying these ecosystems have found that population density across most abyssal plains is remarkably low, especially compared to the crowded ecosystems found near coastlines or coral reefs. A single square meter of abyssal plain might contain only a handful of visible organisms, scattered thinly across an otherwise empty expanse of soft, undisturbed sediment. And yet, across the enormous total area covered by abyssal plains worldwide, this thin, sparse population adds up to an extraordinarily large total number of organisms, quietly living out patient, unhurried lives across the largest habitat found anywhere on our entire planet, almost entirely unnoticed by anyone living on the surface far above them. Researchers conducting long-term surveys of specific abyssal plain sites have found that even sparse populations like these follow subtle, gradual rhythms of their own, tied loosely to the changing seasons occurring far above, near the sunlit surface. When springtime blooms of phytoplankton occur at the surface, the resulting increase in marine snow eventually reaches the abyssal plain weeks or even months later, producing a delayed, gentle pulse of increased activity among the creatures living there, a faint echo of a season they will never directly experience, arriving quietly and gradually, exactly as everything else does in this patient, unhurried world. Beyond deposit feeders like sea cucumbers, the abyssal plain also supports a range of smaller, less conspicuous creatures, tiny worms burrowing gently through the soft sediment, small crustaceans sifting patiently through settled particles, and delicate, almost translucent creatures adapted so completely to the darkness that they possess barely any pigmentation at all, having no evolutionary reason to develop color in a place where nothing, and no one, would ever have the light required to see it. Many of these smaller creatures play a subtle but important role in the broader chemistry of the abyssal plain, quietly turning over and reworking the top layer of sediment as they feed, a process scientists call bioturbation, which helps oxygen and nutrients circulate gently through the otherwise still, undisturbed mud, supporting the dense communities of bacteria that continue the slow work of breaking down whatever organic material has settled there. Scattered across certain regions of the abyssal plain, particularly in parts of the Pacific Ocean, lies one of the strangest and slowest natural resources found anywhere on Earth: small, dark, potato-shaped rocks called polymetallic nodules, sometimes also called manganese nodules, because of the mineral that makes up much of their composition. These nodules form through an extraordinarily slow process, growing as dissolved minerals in the surrounding seawater and sediment gradually precipitate, layer by microscopic layer, around a tiny central core, often a fragment of shell, a shark's tooth, or some other small piece of debris that happened to settle in exactly the right place at exactly the right time. Scientists estimate that these nodules grow at a rate of only a few millimeters every million years, making them among the slowest growing geological formations known anywhere on the planet. A rate so gradual that a nodule roughly the size of a fist might easily be older than the entire history of complex, multicellular life on Earth. Cutting one of these nodules open reveals a structure remarkably similar to the growth rings of an ancient tree, concentric layers built up one at a time, each one recording, in its own subtle chemical composition, the particular conditions of the surrounding deep ocean water at the exact moment that layer formed. In certain regions of the deep Pacific, these nodules cover the seafloor in extraordinary density, sometimes forming an almost continuous, cobbled layer stretching across enormous areas of otherwise flat, featureless sediment. Their unusual mineral composition, containing meaningful quantities of manganese, nickel, copper, and cobalt, has drawn significant scientific and increasingly commercial interest in recent decades, since these are exactly the kinds of metals used widely in modern batteries and electronics. This growing interest has led to considerable debate among scientists, environmental groups, and policymakers, weighing the potential resource value of these nodules against the risk of disturbing an ecosystem that has developed slowly and delicately over millions of years of near total undisturbed quiet, a debate that remains actively unresolved today, playing out gradually, much like the nodules themselves, through careful, patient, international bodies responsible for regulating activity in international waters, have spent years developing careful frameworks intended to balance these competing interests, drawing on research from marine biologists, geologists, and environmental scientists, working to understand exactly how disturbing this ancient, slow-growing seafloor might affect an ecosystem that has had almost no expellion, large-scale disruption. Some researchers have proposed that recovery from any significant disturbance, were it to occur, could take many decades, or even centuries, given how slowly life reestablishes itself in an environment defined so completely by patience and scarcity and unhurried, gradual growth. Some marine biologists have proposed extended pilot studies, deliberately leaving certain small patches of seafloor undisturbed for comparison, precisely so that any future changes can be measured carefully against a genuine, unaltered baseline, an approach that itself requires exactly the kind of patience the abyssal plane seems to demand from everyone who studies it closely, since meaningful results from such comparisons may not become clear for years. In the meantime, these strange, slow-growing nodules continue accumulating exactly as they always have, indifferent to the human debate unfolding somewhere far above them, adding, perhaps, another few atoms of dissolved mineral to their surface tonight, in a process too gradual for any instrument to measure across a single human lifetime, let alone a single, quiet evening. You are lying very still now. The day has grown distant. The thoughts that pressed close earlier have begun to soften at their edges. Your breathing has found its own pace. Slow, easy, unhurried. And as you rest here, I want you to imagine drifting gently downward, through miles of dark, quiet water, until the ocean floor finally comes into view far below you, not jagged or uneven, but smooth and flat and endless, stretching out toward every horizon in perfect, unbroken stillness. There is no sound here, only the faint, distant pressure of deep water surrounding you, and the soft, pale glow of a small light, revealing a landscape so calm and so undisturbed that it feels almost like resting on the surface of a vast, quiet cloud, rather than the floor of an ocean. The sediment beneath you is soft and fine and settled, undisturbed for what might be thousands of years in this particular spot, holding within it a patient, silent record of everything that has drifted down to meet it, one tiny particle at a time, for longer than anyone could ever measure. Imagine yourself settling gently onto that same soft, quiet surface, weightless, supported completely, with nothing at all demanding your attention, nothing at all requiring your effort. There is nowhere else you need to be tonight. There is nothing else you need to do. The flatness here holds no urgency, no incline pulling you forward, no slope demanding that you keep moving. It simply is, endless and calm, exactly the same in every direction, offering nothing but stillness and quiet and rest. Let your body borrow that same stillness now. Let your arms grow heavy and settle exactly where they are. Let your legs soften, sinking deeper into the bed beneath you, the way sediment settles gently onto the abyssal plain, undisturbed, unhurried, perfectly at peace. Somewhere far above you, the ordinary world continues its usual rhythm, tides rising and falling, storms gathering and passing, waves breaking against distant shores. But down here, none of that reaches you at all. Down here, there is only this vast, quiet flatness and your own slow breathing, blending gently into its endless, patient calm. Notice how completely this landscape accepts you, without resistance, without demand. It does not ask you to climb, or navigate, or find your way around any obstacle. It simply extends outward, gently, in every direction, offering exactly the same soft, calm support wherever you happen to rest. Let your own body accept that same offer now. Let your spine soften into the mattress beneath you, exactly the way sediment settles gently into the smallest crevices of the seafloor. Let your hands rest, open and still, needing nothing at all. Let your breathing continue, unhurried, unmeasured, matching the same patient, unbroken calm of the landscape you are resting within tonight. There is no rush anywhere in this vast, quiet world. Even the smallest particles drifting slowly past you seem to understand this, tumbling gently downward without any urgency at all, content to take exactly as long as they need. Exactly as you are allowed to take exactly as long as you need, sinking gradually, effortlessly, into the same soft, welcoming stillness that has held this landscape steady for millions of patient years. Somewhere nearby, a small, unhurried creature moves slowly across the sediment, leaving the faintest trace of its passing. A thin, winding trail that might remain visible for years, undisturbed by anything, in a place where even footsteps, if you could call them that, seem to last almost forever, gently marking the quiet, patient passage of time. One of the most striking features of the abyssal plain, one that becomes especially clear to anyone who has actually visited it inside a research submersible, is its extraordinary silence. On land, and even in shallower parts of the ocean, sound travels constantly, waves crashing, wind moving through water, countless creatures calling, clicking, and communicating in every direction. On the abyssal plain, that constant background noise largely disappears. The water here moves so slowly and so gently that it produces almost no sound of its own. Marine life is sparse enough and generally quiet enough that long stretches of complete silence are entirely normal, broken only occasionally by the faint distant sound of a creature moving somewhere nearby, or the almost imperceptible settling of sediment disturbed by some slow passing current. Researchers who have descended to these depths in crude submersibles frequently describe the experience in strikingly similar terms, an almost meditative stillness, unlike anything encountered anywhere else on the planet, where the loudest sound audible for hours at a time might simply be their own breathing, or the quiet hum of their vessel's own life support systems. This silence is not merely an absence of sound. Scientists studying deep ocean acoustics have found that abyssal plains sit within a distinct acoustic environment, sometimes called the deep sound channel. A layer of water where temperature and pressure combine in such a way that sound waves can actually travel extraordinarily long distances, sometimes thousands of miles, with remarkably little loss of energy along the way. This means that, despite the profound local silence experienced by anyone visiting the abyssal plain directly, the deep ocean as a whole is far from acoustically empty. Whale calls, seismic activity, and even certain types of ship traffic can be detected traveling enormous distances through this deep channel, carried gently along by the same still, undisturbed water that makes the immediate experience of the abyssal plain feel so profoundly and so peacefully quiet. It is a strange and beautiful contradiction, a place of near total local silence, embedded within a vast, patient network capable of carrying faint sound across nearly an entire ocean. Some of the earliest evidence for the deep sound channel came from military research conducted during the Cold War, when scientists discovered that underwater listening stations could detect signals from ships and even certain natural events occurring on the opposite side of an entire ocean, carried along almost entirely undisturbed by this same quiet, deep water layer. Whales appear to have discovered and made use of this same acoustic channel long before humans ever understood its existence, producing low-frequency calls capable of traveling extraordinary distances, allowing individuals to communicate and possibly locate one another across gaps of open ocean that would otherwise make any kind of contact essentially impossible. Scientists studying this acoustic channel have also found that certain low-frequency natural events, distant earthquakes, underwater volcanic eruptions, even large icebergs breaking apart far away in polar waters, can be detected as faint, distant signals traveling silently across entire ocean basins, arriving eventually in the occurred. A quiet, patient messenger service, entirely unintentional, connecting distant corners of our planet in ways that remain largely invisible to anyone living on dry land or standing on the surface. None of this quiet, patient communication ever reaches our awareness, filtered out entirely by miles of water and by the sheer, ordinary business of daily life above the waves. And yet it continues, night and day, season after season, an entire, quiet conversation happening constantly beneath us, entirely independent of whether we ever pause to consider it at all. Exploring the abyssal plain presents scientists with a particular set of challenges, distinct even from the challenges involved in studying the twilight zone or other, shallower parts of the deep ocean. The extreme pressure found at these depths often more than 300 times the pressure experienced at the ocean's surface, requires specially engineered vessels and instruments capable of withstanding forces that would instantly crush ordinary equipment. For decades, much of what scientists learned about abyssal plains came from indirect methods, dredges and sediment cores lowered from research ships far above, gradually building up a picture of the deep seafloor without ever allowing researchers to observe it directly with their own eyes. The development of deep diving submersibles, beginning in the middle of the 20th century, changed this considerably, allowing scientists to descend personally into this vast, quiet landscape, observing its subtle features directly for the first time. More recently, autonomous underwater vehicles, capable of operating independently for extended periods without any human crew aboard, have dramatically expanded scientists' ability to survey abyssal plains across far larger areas than any single submersible expedition could ever achieve. These vehicles can be programmed to travel long, methodical paths across the seafloor, using sonar and high-resolution cameras to build detailed maps of terrain, sediment composition, and the scattered, sparse distribution of life found across these enormous flat expanses. Some research teams have also developed long-term observatories, essentially small, stationary laboratories anchored directly onto the abyssal plain itself, recording continuous data over months or even years, tracking subtle changes in sediment, temperature, and biological activity that would be impossible to detect through occasional, brief visits alone. This patient, long-term style of research suits the abyssal plain particularly well, since so much of what happens here occurs slowly, gradually, over timescales far longer than any single research expedition could ever hope to capture in full. Understanding this landscape, scientists have come to appreciate, requires exactly the same quality the landscape itself embodies so completely: patience, extended over years, sometimes decades, slowly gathering enough careful, quiet observation to begin understanding a place that changes, if it changes at all, at a pace almost too slow for any single human lifetime to fully witness. Some of the longest-running observatories have now been collecting continuous data for well over 3 decades, quietly accumulating one of the most detailed long-term records available anywhere for any deep ocean environment. Researchers returning to these sites year after year often describe a particular kind of patience required for this work, an acceptance that meaningful results might not emerge for years or even decades, and that the value of the research lies precisely in this sustained, unhurried attention, rather than in any single, dramatic discovery arriving all at once. Some researchers have compared this kind of work to tending a very slow garden, one where progress cannot be rushed, where results depend entirely on returning, faithfully, year after year, to observe whatever small, gradual changes have quietly accumulated since the previous visit. It is a style of science that rewards patience far more than urgency, well suited to a landscape that has never once, in its entire existence, been in any particular hurry to reveal its secrets. Perhaps this is why researchers who spend their careers studying the abyssal plain often describe a particular fondness for the work, despite its slow pace and its frequently modest, incremental results. There is a certain contentment, they say, in dedicating oneself to understanding something that will still be there, largely unchanged, long after any single research career has ended. A small, patient contribution to a much larger, much slower story, still quietly unfolding. Though the abyssal plain appears, at first glance, to be almost entirely featureless, closer study reveals subtle variations scattered gently across its otherwise smooth, flat surface. Small hills, known to scientists as abyssal hills, rise gently from the surrounding plain in certain regions, typically no more than a few hundred meters tall, remnants of the original volcanic terrain that has not yet been fully buried beneath accumulated sediment. These hills tend to run in long, roughly parallel lines, tracing the ancient path of the mid-ocean ridge, where the underlying crust was originally formed, millions of years before slowly drifting to its current, distant resting place. Occasionally, a much taller feature interrupts the plain entirely, an isolated underwater volcano, called a seamount, rising dramatically from the surrounding flatness, sometimes reaching thousands of meters in height, tall enough in certain cases to break the surface of the ocean entirely, forming a small island. These seamounts, though relatively rare compared to the vast stretches of flat terrain surrounding them, often support surprisingly dense and varied ecosystems, quite different from the sparse, thinly scattered life found across the ordinary abyssal plain. Rising water currents around a seamount's steep slopes can concentrate nutrients more effectively than the surrounding flat seafloor, supporting corals, sponges, and other filter-feeding organisms in far greater abundance than anywhere nearby. In this way, a single seamount can function almost like an island of relative abundance, rising unexpectedly from an otherwise quiet, resource-limited expanse, drawing life toward it from the surrounding darkness. Much like an oasis interrupts the flat monotony of a desert, scientists have identified thousands of seamounts scattered across the world's oceans, though the vast majority remain entirely unexplored. Hidden beneath the surface, known only through satellite gravity measurements, capable of detecting the subtle way a large underwater mountain slightly distorts the surface of the ocean directly above it. Each of these isolated peaks represents its own small, largely unstudied world, rising quietly from the vast, patient flatness of the abyssal plain surrounding it, waiting, much like the plain itself, for researchers patient enough to eventually make the long, slow journey down to study it directly. Seamounts are also increasingly recognized as important stepping stones for the broader distribution of deep-sea life, offering isolated patches of relative abundance that certain species may use as stopping points, while gradually spreading across enormous distances of otherwise resource-poor open ocean. Some researchers have compared this pattern to island chains found on the surface of the planet, isolated points of habitat, separated by vast stretches of comparatively empty terrain, each one supporting its own distinct, slowly evolving community, shaped by whichever creatures happen to successfully make the long, difficult journey between one seamount and the next, sometime across a span of many thousands, or even millions of years. Some of the most spectacular seamounts, once their peaks reach close enough to the sunlit surface, develop entirely different ecosystems still: coral reefs, kelp forests, or rich fishing grounds, supporting communities of life almost unrecognizable compared to the quiet, sparse world found on the surrounding abyssal plain far below. A striking reminder of just how dramatically conditions can shift across what might otherwise seem like a ocean. Between these two extremes, the barren stillness of the deep plain and the sudden abundance of a seamount or reef, lies an entire gradient of transitional environments, each one shaped by its own particular depth, its own particular exposure to currents, and its own particular distance from whatever nutrient source happens to be nearest. A patient, continuous spectrum stretching from total scarcity to relative abundance, all contained within the same enormous, largely unified ocean. The relationship between the abyssal plain and the marine snow we explored during an earlier evening together runs deeper than simple proximity. In many ways, the abyssal plain exists precisely because of that same slow, patient rain of organic material, its smooth, level surface built gradually, layer upon layer, from exactly the kind of falling debris that connects the sunlit surface of the ocean to its darkest, most remote depths. Every centimeter of sediment covering the abyssal plain represents an almost unimaginable accumulation of individual particles, each one having completed its own long, unhurried descent from waters far above, before finally settling, gently, into place. Scientists studying sediment cores, recovered from abyssal plains, have found that accumulation rates here are extraordinarily slow, sometimes as little as 1 centimeter every 1,000 years, meaning that even a relatively short sediment core can preserve an uninterrupted record stretching back hundreds of thousands of years into the past. This makes abyssal plains particularly valuable to researchers studying the long-term history of our planet's climate, since the sediment accumulating here remains largely undisturbed by the strong currents, storms, and biological activity that can complicate similar research in shallower, more turbulent parts of the ocean. Layer by patient layer, these sediments preserve a remarkably clear record of ancient ocean temperatures, ancient ocean chemistry, and the broader climate patterns that shaped our planet long before any human observer existed to measure them directly. In this sense, the abyssal plain functions almost like an enormous natural archive, quietly compiled over millions of years, storing information nowhere else on Earth preserves with quite the same patient, undisturbed clarity. Researchers drilling deep into these ancient layers have recovered sediment cores stretching back tens of millions of years, each one offering a slow, careful glimpse into a planet that looked and behaved quite differently than the one we know today, all of it recorded patiently by the same quiet, unhurried snowfall that continues drifting downward, even now, settling gently onto the vast, flat plain far below. Some of the most valuable sediment cores ever recovered from abyssal plains have come from regions near the boundary between two of Earth's major geological eras, preserving a clear, undisturbed record of the dramatic environmental changes that occurred during those ancient transitions. In certain locations, researchers have identified thin, distinct layers within the sediment corresponding to specific catastrophic events in Earth's distant past, evidence of ancient asteroid impacts, or sudden, dramatic shifts in ocean chemistry, preserved with remarkable clarity precisely because the abyssal plain accumulates its sediment so slowly and so undisturbed compared to almost anywhere else on the planet's surface. Beyond catastrophic events, these same patient sediment layers also preserve gradual, subtle transitions, the slow warming or cooling of ancient oceans, the gradual shifting of major ocean currents, and even, in certain remarkable cases, the faint chemical signature left behind by ancient volcanic eruptions occurring thousands of miles away, carried gently to the abyssal plain by ash and dust-settling snowfall of marine particles that has always defined this quake. Reading a single sediment core, patiently, layer by layer, can feel almost like reading a very long, very quiet letter, written slowly over millions of years, addressed to whichever curious mind eventually arrives to read it. Researchers analyzing these layered records often compare the process to reading a very long, very slow letter, written not in any human language, but in the patient chemistry of settling shells and sediment, a message composed gradually over millions of years, waiting quietly for anyone patient enough and skilled enough to finally learn how to read it properly. The physical conditions found across most abyssal plains remain remarkably stable and consistent, a striking contrast to the dramatic seasonal shifts experienced in shallower waters or on the surface of the continents above. Water temperature at these depths typically hovers just above freezing, often between 0 and 4 degrees Celsius, and remains almost perfectly constant throughout the entire year, unaffected by the changing seasons that shape conditions closer to the surface. This remarkable stability extends to nearly every other measurable condition as well. Pressure remains essentially constant, since depth changes only very gradually across the gently sloping terrain of a typical abyssal plain. Salinity and the overall chemistry of the surrounding water similarly remains steady, changing only very slowly, over timescales measured in centuries rather than seasons. For the organisms adapted to life in this environment, this stability represents both an advantage and a constraint. Creatures living on the abyssal plain rarely need to cope with sudden temperature swings or dramatic shifts in their surrounding chemistry, the kind of environmental stress that shapes so much of life closer to the surface. But this same stability also means that abyssal organisms are often poorly equipped to handle sudden change, when it does occasionally occur, whether from a passing research vessel, a shift in deep ocean currents, or increasingly, the gradual influence of a changing climate reaching even into these remote, previously stable depths. Scientists studying long-term data collected from abyssal observatories have begun detecting subtle but measurable changes in recent decades, small shifts in temperature, and small changes in the amount of organic material reaching the seafloor. Changes that would have been considered essentially impossible within the timescale of a single human lifetime, based on everything previously understood about the remarkable patient stability of this environment. These findings have added new urgency to abyssal plain research, since understanding exactly how, and how quickly, this vast, stable habitat might respond to a changing climate requires exactly the kind of long-term, patient observation that scientists have only recently begun to establish across these remote, historically understudied regions of our planet. This gradual warming trend, though still small compared to changes observed in shallower, more exposed parts of the ocean, is being watched closely by researchers precisely because the abyssal plains ecosystems evolved within such an unusually narrow range of stable conditions, over such an extraordinarily long period of time, that even modest shifts could eventually prove more disruptive here than comparable changes might be in environments already more accustomed to regular fluctuation. Researchers have begun comparing notes across different abyssal observation sites scattered around the world, hoping to determine whether these subtle shifts represent a broad, global pattern, or instead reflect more localized changes tied to specific regional currents or nearby human activity. Either way, the growing body of long-term data now available represents an entirely new kind of scientific resource, one that simply did not exist a few decades ago, offering researchers their first genuine opportunity to observe, in real time, exactly how a landscape defined for millions of years by stability might begin responding to a world that is, itself, changing somewhat more quickly than it once did. There is something worth sitting with in this quiet vulnerability, a landscape so patient, so accustomed to stability, now facing the possibility of change on a timescale far faster than anything it has ever encountered before. A reminder that even the most enduring, most unhurried systems on our planet are not entirely separate from the broader, faster-changing world happening far above them. Life on the abyssal plane has evolved a number of remarkable adaptations, shaped patiently over millions of years by the particular combination of darkness, cold, extreme pressure, and limited food that defines this environment. Bioluminescence, the ability to produce light through natural chemical reactions, is especially common among creatures living at these depths, serving a range of purposes entirely different from anything found near the sunlit surface. Some creatures use bioluminescence to attract prey, dangling a small, glowing lure directly in front of their mouths, patiently waiting for a curious smaller creature to approach close enough to be caught. Others use it defensively, releasing a sudden burst of light to startle or confuse a potential predator, buying just enough time to escape into the surrounding darkness. Still others use bioluminescence for communication, signaling to potential mates across the vast, dark emptiness of the abyssal plane, where visual recognition through ordinary means would be entirely impossible. Beyond light production, many abyssal creatures have evolved extraordinarily slow metabolisms, allowing them to survive on remarkably little food for extended periods. Certain deep-sea sponges, for example, have been found growing at rates so slow that individual colonies are estimated to be many thousands of years old, essentially motionless, patient structures that have remained in roughly the same spot on the seafloor since long before recorded human history began. Some deep-sea corals discovered on and near abyssal plains have been dated as being over 4,000 years old, quietly continuing to grow, a few millimeters at a time, throughout the entire span of recorded human civilization, entirely undisturbed by anything happening on the surface of the planet far above them. This combination of patience and extraordinary longevity appears again and again throughout abyssal plain ecosystems, a landscape and a community of creatures seemingly built around the principle that slow, steady, unhurried persistence, rather than speed or abundance or rapid growth, represents the most successful strategy for surviving in one of the most resource-limited and most stable environments found anywhere on our entire planet. Some of the oldest known living organisms on Earth are believed to reside within or near abyssal plain environments, deep-sea black corals, and certain sponge species whose age, determined through careful radiocarbon dating, suggests lifespans stretching well beyond 10,000 years, older than agriculture, older than writing, older than nearly every human civilization that has ever existed, entirely undisturbed by any of it. Researchers studying these ancient organisms often describe a particular kind of humility that comes from working with them directly, an awareness that a single careless movement or a single moment of disturbance could damage something that took many thousands of years to grow, and that no amount of future patience could ever fully restore within any human lifetime. This awareness has shaped much of modern deep-sea research, encouraging increasingly careful, minimally invasive methods designed specifically to observe and to learn without disturbing the extraordinarily slow, extraordinarily patient rhythms that define life across the abyssal plain. Even the process of collecting a single small sample from one of these ancient organisms requires extraordinary care, since removing even a small fragment might represent centuries, or even millennia, of accumulated growth, an amount of time no researcher could ever hope to witness personally recovering, should the disturbance prove more damaging than intended. This careful restraint has become something of a guiding principle throughout modern abyssal research more broadly, a recognition that curiosity, however genuine, carries with it a responsibility to tread lightly in a place that has spent millions of years accumulating exactly the kind of delicate, patient stability that a single careless moment could disrupt for far longer than any of us will be alive to witness its slow, gradual recovery. There's a quiet symmetry worth considering between the vast, patient flatness of the abyssal plain and the equally vast, patient stillness of deep space, a comparison scientists studying extreme environments have drawn increasingly often in recent years. Both represent enormous expanses, largely uniform, largely undisturbed, shaped gradually over timescales that dwarf any single human lifetime. Both exist in near total darkness, illuminated only occasionally by faint, scattered light, whether the distant glow of starlight or the bioluminescent flicker of a creature drifting slowly across the ocean floor. And in both places, life, where it manages to persist at all, has adapted not toward abundance or rapid growth, but toward patience, toward slow, careful conservation of whatever limited resources happen to be available. Researchers studying the abyssal plain have noted that understanding this remote, resource-limited environment offers useful insight into how life might exist elsewhere in the universe, particularly within the hidden subsurface oceans believed to exist beneath the icy crusts of certain distant moons, environments that likely share many of the same basic conditions found here: extreme cold, extreme pressure, complete darkness, and a limited, unpredictable supply of nourishment arriving slowly from above. In this sense, exploring the abyssal plain becomes, in a small but meaningful way, a form of practice for exploring worlds we have not yet reached, a chance to understand, directly and firsthand, how an entire ecosystem might successfully organize itself around patience rather than plenty, around slow, careful persistence rather than rapid, energetic growth. It is a landscape that asks nothing in a hurry and offers in return some of the clearest lessons we have found anywhere on Earth about what it actually takes for life to endure, quietly and successfully, across truly enormous stretches of time. Some astrobiologists have gone further still, suggesting that if life is ever discovered beyond Earth, it may well resemble the quiet, patient organisms found on our own abyssal plains far more closely than it resembles anything familiar from the sunlit, energetic world most of us know, slow, small, and unhurried, shaped entirely by scarcity and by the enormous stretches of time available to any process patient enough to make use of them. In this way, studying the abyssal plain is not simply about understanding our own ocean more completely, though it certainly accomplishes that as well. It is also, in a quiet, indirect way, a form of preparation, a chance to develop exactly the kind of patient, careful thinking that scientists suspect will eventually prove necessary, should humanity ever succeed in discovering and attempting to understand another form of life entirely, patiently persisting somewhere else, in conditions not unlike the vast, dark stillness resting quietly beneath our own familiar ocean waves. There is a certain humility built into this comparison as well. For all of humanity's technological achievement, we remain, in a very real sense, still learning how to properly explore even our own planet, let alone anything beyond it. The abyssal plain, quietly stretching across nearly half of Earth's entire surface, largely unmapped, largely unstudied, remains a reminder that vast frontiers do not always require a rocket to reach. Sometimes, they simply require patience, careful engineering, and a willingness to descend, slowly, into darkness, in search of understanding that reveals itself only gradually to those willing to wait for it. Perhaps this is the quiet gift this landscape offers anyone willing to sit with it for a while, tonight included, a reminder that understanding and rest and meaningful discovery rarely arrive all at once, but instead settle, gradually, gently, exactly like sediment, exactly like sleep, one patient layer at a time. As we come gently toward the end of our time together tonight, let us sit for a moment with the quiet lesson offered by the abyssal plain itself. Here is a landscape that asks for nothing and expects nothing, content simply to exist, flat and quiet and undisturbed, exactly as it is, without needing to prove itself through height, or drama, or dramatic change. Mountains rise and erode and rise again. Coastlines shift with every tide, but the abyssal plain simply remains, patient and unhurried, absorbing whatever gently settles onto it, adding, slowly, to its own quiet history, without ever needing to announce itself, or demand attention, or compete for recognition with the more dramatic landscapes found elsewhere on our planet. There is a gentle permission hidden in that quality. If you are willing to rest with it for a moment tonight, you do not need to be dramatic or urgent or constantly changing to be worthwhile. Sometimes, simply existing steadily and patiently, exactly as you are, is entirely enough. Exactly the way an entire ecosystem has learned to thrive across the largest habitat on our planet, not through speed or abundance, but through quiet, patient persistence, one small, unhurried moment settling gently onto the next. You are allowed that same quiet permission tonight. You do not need to accomplish anything more before you rest. You do not need your thoughts to resolve themselves into anything dramatic or complete. You can simply let them settle, gently, the way sediment settles onto the abyssal plain. One small thought at a time, undemanding, unhurried, gradually forming a soft, quiet stillness around you. Exactly the kind of stillness that has patiently covered the largest landscape on Earth, one gentle layer at a time, for longer than anyone could ever measure. Think, for a moment, about how much quiet strength there actually is in simply enduring, without needing to announce it, without needing anyone else to notice. The abyssal plain has never once needed recognition to continue existing exactly as it is. It has never needed an audience to justify its own vast, patient stillness. It simply continues, exactly as it has for millions of years, entirely secure in its own quiet worth, regardless of whether anyone above ever thinks about it at all. You are allowed that same quiet security tonight, resting exactly as you are, without needing anyone's attention, or approval, or acknowledgement, to make this moment of rest entirely, completely valid. Let that same quiet security settle into your chest now, rising and falling gently with each breath, needing no permission, needing no witness, simply existing, exactly as it is, exactly as the vast, patient plain far beneath the ocean continues existing tonight, undisturbed, unhurried, and entirely, completely enough, just as it is. Let that same enoughness settle into you now, quiet, complete, requiring nothing further. Exactly as you are, exactly as this moment is, resting, undisturbed, at the end of a long day. Let that same permission extend gently through the rest of your body now, down through your hips, down through your knees, down through your feet, each part settling a little further, a little more completely, into the soft support beneath you, needing no effort, no adjustment, nothing at all beyond simple, patient rest. There is nothing to fix here, and nothing to solve. Only the same quiet invitation. The abyssal plain itself has always offered every particle that has ever drifted down to meet it. Simply arrive, simply settle, simply become part of the vast, patient stillness, exactly as you are. As we slowly rise back now, from the vast, quiet flatness of the abyssal plain, from the slow-growing nodules and the ancient, patient corals, from the profound silence that fills this landscape far below the reach of any storm or tide, let everything we explored together tonight settle gently into your mind. We began with a landscape larger than any other habitat on Earth, built slowly, one particle at a time, from millions of years of patient, settling sediment. We learned how life persists here, sparse and slow, and remarkably adapted to a world defined by scarcity and stillness and near total darkness. We considered the profound silence of this place, and the surprising way that same stillness allows sound to travel farther here than almost anywhere else in the ocean. And we thought about the quiet lesson this landscape offers, that patience and steady, unhurried persistence can be enough, entirely enough, without needing anything more dramatic to justify their own quiet worth. Through all of it, one idea remained close. Flatness is not emptiness. Stillness is not absence. The abyssal plain, quiet and unremarkable as it may first appear, holds within it an entire patient world, worthy of exactly the same rest and the same gentle attention that you are giving yourself right now. There's nothing more you need to hold on to tonight. Let that vast, quiet plain continue its own slow, patient existence, somewhere far beneath you, undisturbed and calm. Let whatever thoughts remain from today settle just as gently, and let yourself sink deeper into a slow, unhurried rest of your own. Exactly the kind of rest this entire landscape has spent millions of years quietly, patiently, teaching us to value. Somewhere, right now, sediment is settling gently onto the abyssal plain, exactly as it has every single day for millions of years, one microscopic particle joining countless others, adding almost imperceptibly to a landscape that will still be quietly forming, long after tonight, long after tomorrow, long after every ordinary day that follows it. Patient and unhurried, exactly as it has always been. And somewhere within you, right now, the same quiet, patient process is beginning. Thoughts settling gently, one at a time, layer upon layer, gradually forming the same soft, undisturbed stillness that will, in its own unhurried time, carry you fully into rest. There is a quiet symmetry in that thought worth resting with for a moment. The same patient process that has spent millions of years building the largest, calmest landscape on our entire planet is, in its own small way, mirrored tonight, within your own body, thoughts settling, breath slowing, tension dissolving, layer by gentle layer, until nothing remains but stillness, undisturbed and complete. Let that stillness carry you now gently, the rest of the way. Exactly as the abyssal plain has always carried whatever settles softly onto it, without resistance, without hurry, simply holding, patiently, whatever arrives. There is no need to force this process along. Just as sediment cannot be rushed into settling any faster than it naturally will, your own mind cannot be forced into stillness through effort or insistence. It can only be gently invited, softly, patiently, exactly the way this vast, ancient landscape has always welcomed whatever quietly drifts down to meet it, without judgment, without hurry, simply accepting each small arrival in its own unhurried time. If you are still here with us, another quiet journey is waiting for you on some other evening soon. And if tonight's journey helped carry you a little closer to sleep, a like, a subscribe, or a gentle comment helps other tired minds find their way here too. There is nothing left to think about tonight. There is nothing left to plan or solve or worry over. Just this quiet room, this soft darkness, and the slow, steady rhythm of your own breathing, carrying you gently further and further from the day that has already, quietly, let you go. Somewhere far beneath the surface of the ocean, invisible in the darkness, the abyssal plain continues its own patient existence, flat and calm and undisturbed, exactly as it has for millions of years, and exactly as it will continue to, long after tonight has quietly become tomorrow. You are allowed that same patience tonight. You do not need to hurry towards sleep. You only need to let go, gently, the way sediment settles softly onto a landscape with nowhere else it needs to be. Let your body remain heavy and warm and still. Let your thoughts continue to soften and slow and settle the way this entire vast, quiet plain has settled, gently over millions upon millions of patient, unhurried years. Whatever tomorrow holds, it can wait. For now, there is only this room, this breath, and the slow, patient dark settling gently around you, the same patient dark that has quietly covered the largest, calmest landscape on our entire planet, and that now, for tonight, simply holds you too. Think back, for just a moment, to where this journey began, with a vast, quiet plain, larger than any other habitat on Earth, formed slowly, patiently, one particle at a time. You do not need to remember any of the details. You only need to carry with you the same quiet patience that shaped it, the same gentle willingness to let things settle, slowly, exactly as they need to, without hurry, without effort, without anything at all required of you, except simply, softly, letting go. There is nothing left to figure out tonight. There is nothing left to plan, or arrange, or worry into place before you allow yourself to rest completely. The plane will still be there tomorrow, exactly as flat, exactly as calm, exactly as patient, whether you think of it again or not. All that is asked of you, right now, is exactly what is asked of a single grain of settling sediment. Nothing at all beyond simply continuing to rest, softly, wherever you happen to be. Let this be enough for now. Let the quiet weight of everything we have traveled through together tonight, the vast, flat plain, the ancient corals, the profound and patient silence, settle gently around you, undemanding, unhurried, asking nothing more of you than simple, patient rest, exactly as it is, exactly as you are, right here, right now. There is nothing more to add tonight, and nothing more required of you. Just this quiet room, this patient dark, and the same slow, unhurried settling that has shaped the largest, calmest landscape on our entire planet. Now gently, softly, shaping your own rest as well. From the sleep journal, and from one tired mind to another, across the soft, patient dark of tonight. Sleep well, rest gently, and good night.